Today we're going to be talking about quadratic inequalities. And we've already talked about the linear and absolute value ones, and now we're going to move on to quadratics. So when we talk about quadratic inequalities, what we're going to want to do is try our best to get the equations equal to 0 and see if we can factor them. Because if we can get the equations equal to 0, then testing a point becomes a heck of a lot easier, and that will allow us to solve our inequality. So let me show you what I mean by that. So you might be tempted to do the square root of both sides and have your two solutions be plus or minus 2. But what I think would be better long term, and that may be easier for this specific problem, but when we get to harder problems, that method isn't going to work. So what I would want to do is subtract 4 from both sides, so then we have x squared minus 4 is greater than 0. Then we can factor that. That's a difference of two squares. So we have x minus 2 times x plus 2 is greater than 0. So if you remember graphing quadratics in intercept form, we would have our two intercepts at positive 2 comma 0 and negative 2 comma 0. This one right here would give negative 2 comma 0. This would be positive 2 comma 0. And we also know that this quadratic is opened upwards because our a value is positive. We have positive x squared. So a rough sketch of this quadratic, I'll use a different color. A rough sketch of this quadratic would look like this. And back to our inequality part, we say we want this to be greater than 0. Well, remember in the coordinate plane that this is your x-axis and this is your y-axis. So if I want my value to be greater than 0, I want everything above the x-axis. So this part of the graph is above the x-axis, so that would be when this function is greater than 0. Anything below would be less than 0, and equal to 0 would be right on the x-axis. So we go and look at our graph and say, well, when x is less than negative 2, I have my y values up here, and when x is greater than 2, my y values are up here above the x-axis. So we would say our solution is negative infinity comma negative 2, and so that union 2 comma infinity. Now another way you could have done this would be to again have your graph and test a point. Okay, so we can test 0 for x. If we test 0 for x, 0 squared minus 4 is greater than 0. That's not true because that becomes negative 4 is greater than 0. So that means that this area here is not included in our solution. So then the other parts would have to be. All right, so then number 2, again, it may be very tempting just to square root both sides, but to get it in standard form will make life easier. So we're going to FOIL that out using the shortcut for a perfect square trinomial. So it's going to be x squared minus 6x plus 9 is less than or equal to 81. Subtract 81 from both sides. X squared minus 6x minus 72 is less than or equal to 0. Okay, now we can factor this. X squared minus 6x minus 72 factors to x minus 12 and x plus 6. 12. Okay, so then we can draw our rough sketch, and we have -6. So -6 we know is over on this side, and 12 is over here. So we don't even need to draw in all the tick marks. We just need to plot our x-intercepts. And again, if we look at this equation in standard form, our a value is +1. So this parabola will be opening upwards. So something like this. We don't need to know the vertex or anything. So we'll look and see, when is this less than or equal to 0? So we want this part right here, below the x-axis. And because it's less than or equal to, we're going to use brackets. So our solution is from -6 to +12. That is when this quadratic has y values that are less than 0. So then number 3, you see this one is not in vertex form. This is in standard form. So it will be easier to subtract 2 from both sides, and then we have x squared minus 4x minus 12 is greater than 0. Factor that. This factors into x minus 6 times x plus 2. So then we'll do our rough sketch. Our two x-intercepts will be -2 and +6. Our a value is positive. We don't have a negative sign in front, so our quadratic opens upwards. And our inequality sign is greater than, so we want everything above the x-axis, but not including the x-axis, so we're going to use parentheses. So we have -infinity, comma, -2, and +6, comma, +infinity as our solution. So you see that the work we did last year graphing quadratics in intercept form is helping us now. Number 4, subtract 3 from both sides. We get x squared minus 2x minus 3 is greater than or equal to 0. Then we're going to factor this to x minus 3 times x plus 1 is greater than or equal to 0. Right, then we have our rough sketch, and our two x-intercepts will be at +3 and -1. Positive a value, positive number in front of x squared, so our parabola opens upwards. And it says greater than or equal to 0, so we want everything above the x-axis, including the intercepts. So we're going to say -infinity, comma, -1 with a bracket around -1 with the union of 3, comma, +infinity. You might be tempted to say, well, I can factor this already, but we don't have it less than or greater than or anything. We don't have a 0 on the other side, so we want to subtract 16 from both sides. So x squared minus 6x minus 7 is less than 0. So then we'll factor that and get x minus 7 times x plus 1. So we'll draw a rough sketch. We have +7, and we have -1, positive a value, so it'd open up like that. Oops, I forgot the less than 0 part. And then since we are less than, we want everything underneath the x-axis. and this will give us an interval from -1 to +7, and since we don't have less than or equal to, just less than, we don't need brackets. So you're going to get a lot of practice sketching these quadratic functions by doing this, and it makes these problems a lot easier than trying to take the square root and testing points a bunch of times. We can just draw the graph and then highlight the area underneath or above. So thanks for watching. Make sure to like the video and subscribe.